Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah. Let us open our session, our industrial seminar talk under Thermofluid Research Group, Department of Mechanical and Aerospace Engineering, with recitation Al-Fatihah. Alhamdulillah. Iyyaka na'budu wa nasta'in. Shiratal mustaqim. Shiratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim. Ini sadaqallahul azim. Melati kuntum tumbuh melata, sayang merbah di pohon cemara. Assalamualaikum mulanya kata, saya sembah pembuka bicara. Indah berbalam di awan petang, berarak di celah pepohon ara. Pemanis kalam, selamat datang, awal bismillah pembuka bicara. So everybody, welcome to our seminar talk. So we are really honored to invite our guest speaker, Professor Dato TS Dr. Kamaruzzaman Sopian. He's from UKM under SERI, Solar Energy. So before that, I think everyone knows who is Prof. Kamaruzzaman Sopian. So currently he is the third scientist in Malaysia and 56 scientists in the world. So he's among the 1% scientists in the world, mashallah. So before that, let me introduce you of our speaker. So our speaker from UKM. So he's SERI expertise. Prof. Dato TS Dr. Kamaruzzaman graduated with the BS Mechanical Engineering from University of Wisconsin-Madison in 1985, the Master's degree in Energy Resources, University of Pittsburgh in 1989, and PhD in Mechanical Engineering from Dorgan Solar Laboratory, University of Miami, Coral Gables. Betul, Prof? His main contribution are in solar radiation modeling and resource assessment, advanced solar photovoltaic system, grid-connected photovoltaic, solar-powered regenerative fuel cell, solar hydrogen production, thin film silicon solar cell, and advanced solar thermal system, solar cooling, solar heat pump, solar-assisted drying, combined photovoltaic thermal or hybrid collector. He has 10 patents, 15 patents pending, 6 copyright and 1 trademark for his innovation in renewable energy technology. The innovation and invention in renewable energy technology have won over 90 medals in national and international innovation and invention competition, including Special Innovation Award. He was conferred the Darjah Datuk Paduka Mahkota Perak by His Royal Highness the Sultan of Perak in 2013. A fellow of Malaysia Academy of Science, professional technologies with the Malaysia Board of Technologies, PTEC, and listed in 2019, 2020, I think 2021 also, probably. Highly cited researcher by Web of Science Group, Creative Analytics. I think he's more than expert in this field for many years. So without further ado, let's invite Prof. Dato Kamaruzzaman to present his speech today on solar thermal technology, inshallah. Fayatafadhal mashkura, Prof.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillah. Bismillahirrahmanirrahim. Allahumma salli ala Muhammad wa ali Muhammad. Okay, I'm going to give a presentation today on solar thermal technology for the tropics. I will this is the first time that I have to give presentation in 2 platforms. So I'm controlling 2 computers, 2 laptops. I will begin with some introduction. And the introduction will essentially delve into the tropics, actually. And then what are the types of solar energy technology which are suitable in the tropics? Because the tropics is a very special region. I will then go into some practical application of solar thermal system, including solar assisted drying systems, solar water heating system, desalination system, solar air conditioning system, and a special type of collector known as photovoltaic thermal collector, which is actually a combination of thermal as well as photovoltaic collector into one unit. And finally, I will share to you some of my thoughts for those who want to start a lab in solar thermal. What are the things that you need? What are the essential equipment that is the basic equipment that is needed?
Can I record?
Please.
Oh, dah. Alright.
Okay. And finally, I will present, as I said earlier, for those who are interested to start the solar thermal lab, what are the essential things that you need? And the energy resource of the world, if you see in this particular PowerPoint, that it is solar radiation, geothermal, wave tidal, marine current, and nuclear energy. They are considered to be primary energy. And in solar radiation, you have direct solar, and then you have which is photovoltaic and thermal collectors that we are going to discuss today. And then you have stored solar, which are renewable biomass, for example, renewable stored solar, and non-renewable solar, for example, fossil fuel, namely petroleum, natural gas, coal, and shale. And finally, you have the last classification for solar radiation is indirect solar, which include wind and hydro. And for today, we are going to look into this particular technology, and which is known as solar thermal technology. And some of the latest development in using photovoltaic as thermal collectors. And before we go into the solar energy, I would like to introduce you some fundamental aspect of solar radiation. When I evaluate many papers and read many papers for journal, the use of radiation has been used sometimes incorrectly. Irradiance referred to on an hourly basis what is the radiant power or radiant flux per unit area. In solar energy, we always look into per unit area. And this is called irradiance. Irradiance. The unit is power unit. So irradiance is measured in watts per meter square and has sometimes have a symbol of E that is used in many literature. Now, before that, what I would like to say here is that there are three types of solar irradiance. Three types. Number one is the global. Global means inclusive of three particular components. Number one is the direct component, number two is the diffuse component, and number three is the reflected component. The direct component is the one that you can notice on a blue sky. It means that you have high direct component. The second one is the diffuse component. The diffuse component is the component that has been already passed through the clouds and then being absorbed by the clouds. So what reached the Earth is only the diffuse component. In the tropic, the diffuse component is a lot. The diffuse component can be until 40, 50, 60%. But if you look at countries where the direct solar radiation is predominant, the direct component is sometimes 90%. You can easily identify this when you look at the sky. If the sky is blue, it means that the direct component is high. When the sky is cloudy, then the direct component is very low. Now, why this is important? Because some collector only utilize the direct component. For Malaysia, we are characterized by diffuse radiation. We have almost 60% diffuse. We are also characterized by 170 rainy days. We have only 3 days where the sky is blue. So therefore, you can see that some type of collector, especially the concentrating type collector, is not of practical use in Malaysia. But there are some concentrating type collector, for example, the compound parabolic collector, which has a high acceptance angle, that can be utilized under our local condition. So, 3% 3% of the day, or sorry, 1%, only 1% of the day out of the 365, we have the blue sky. The rest of it are just diffuse sky. So therefore, to understand what type of solar thermal system that can work in Malaysia, you have to understand the solar radiation characteristics. It's like the Malay proverb, tak kenal maka tak cinta. You have to know the solar radiation sources first. So the tropics are characterized by diffuse and also for rainy days. Sometimes the rainy days are good because why? It acts as a natural cleansing mechanism for your collector. Most of our rainy days are rainy days in the afternoon. So in the afternoon also, most of the solar collector after 3 o'clock, it doesn't work anyway. So therefore, that rain essentially will act as a natural cleansing mechanism for your collector. That's the reason why the energy for Malaysia is, although we are diffuse, we have higher energy as opposed to some of the Middle East countries. So, because a lot of dust accumulation on the collector, and I would like to tell you that dust accumulation on solar collector, be it thermal collectors or PV collector, will basically reduce the performance even by 50%. So, that diagram shows you the irradiance, and it is in the unit of kilowatt or watt energy unit, power unit. And then you have the next one, when you integrate the area under the curve. This unit is an energy unit. That's why you have kilowatt hour. Energy unit is different from the unit as I mentioned earlier, which is a power unit. One deals with hourly, the other deals with the average throughout the day. Therefore, when you look at some of the solar radiation mapping, it gives you this diagram, this value, not the irradiance, but the irradiation. Yeah? So this is the two different altogether. Yeah? So, and now by knowing that, if you look at this particular graph, this particular picture, which is the global horizontal irradiation. This is the global, meaning that it composed of the direct, it also composed of the diffuse, and also of the reflected, all of that. So you can see from this graph, this is the global, you can see some of the area which is red. Now, let me tell you, let's see in Malaysia. Malaysia is 5.0 kilowatt hour per meter square of average irradiation for the year. So this is we call this average daily solar irradiation for Malaysia is about 5.0. Don't worry about things, but what you need to know is that you have 5, you are in the tropics, but if you have 7, it means that you are in the arid desert region. But that doesn't show the whole story. There's another one, the direct normal irradiation. Look at Malaysia, our direct tu tak kuat sangat, that's not strong. Our diffuse is strong because it's an inverse relationship to that. So with that in mind, you can see that not all type of collector, especially the one that has to do with concentrating collector, is practical under the normal irradiation condition. It works, yes, but it works as a specific type when the sky is blue. So what it means? It means that we have a lot of potential for flat plates, evacuated tubes application, and so forth. Now, let's look into the solar thermal energy and the classification. Number one, you have solar thermal collectors, and in solar thermal collectors, you have the flat plate collector. These are the one that you can see a lot, and you have sometimes the unglazed solar collector, the one that is without the glass top. And then you have the direct absorption solar collector, and then you have the concentrating solar collector. This is the type that which require a lot of the direct component because it has to concentrate on a spot. When the passing cloud comes along, it will basically disperse the concentration. And then you have the evacuated tube solar collector. And then followed by the second, which is the photovoltaic thermal collectors, which I'm going to cover later on. And then on the solar pond is a surface of water, where you can collect some heat using the pond. But it's not very suitable in areas with a lot of rain because it will disturb the desalination the gradient of the solar pond. And then you have an important area, it's called thermal storage. You have to store it. And if anybody wants to start a new research program, thermal storage will be another program that you can start. You can use many of the latest material to essentially store thermal energy. And then you have solar steel. Solar steel is, there are many types. Solar steel is for desalination process. And for solar steel, you have the solar steel, the double slope, and of course, some solar distillation system. So these are the solar thermal technology. And then most of you are mechanical engineers, right? So therefore, you can see that from the second law analysis, now we are in the latest round of latest research in solar thermal technology, because it involves working fluid, because also it involves a lot of heat transfer. Therefore, the use of nanofluids has been allowed. And you see in the literature, these are things that it's not something new before, nanofluids, but it is something that is emerging. Because the reason is simple. When you use nanofluids, from the first law of aspect is going to increase your heat transfer. From your second law aspect, it is going to be beneficial for the economics because your collector is going to be smaller. One of the issue for solar thermal collector is that it requires a lot of space. So space is something which is directly linked to the cost. So therefore, when you use nanofluids, your exergy destruction is going to be lower. So therefore, you are going to have smaller and more compact solar collector by using nanofluids. And then, as far as the environmental is concerned, that environmental damage due to the use of nanofluids will be decreased. And of course, you're going to have energy. You're going to save energy. So Enhancements in nanofluids, for example, will involve increase in thermal conductivity, better heat transfer coefficient. Of course, you have some high pressure drop, but that will be covered by, and you have the decrease in the entropy generation, and this will result in reduction of collected area and the reduction in emission. Now, what are nanoparticles? This give you an indication of the relative size of the nanoparticle compared to the others. Now, we look into some of the application of this in solar thermal collector. This is a concentrating collector, and the concentrating collector is essentially a collector. It's a parabolic that you concentrate the solar radiation into one point or one line, and then you will receive a lot of heat from that, and you can use nanofluids as one of the fluid for heat transfer. But of course, as I mentioned earlier, look at the sky behind that concentrating collector. What color is it? It almost blue, something which is very rare for the tropics. But with some modification, you can use it. You can modify, for example, if you look at parabolic collector, it has a single focus. You can widen the focus by making this collector compound parabolic. And research has been done in Malaysia by using CPC, because the angle of acceptance now is not a point, but it's a much broader area. So therefore, you can follow the sun. And then the solar hot water heating system. Solar hot water heating system either uses the thermosiphon system or using a pump. And you have a tank that is, you can use nanofluid as part of the working fluid for the collector, and this will enhance the heat transfer. And for solar pond, it's the same thing. Now, what you see in the solar pond is that when you have fluid that has stratification, it means that the top and the bottom has different salinity value. So therefore, it is like a solar collector. You can collect heat at the bottom of the pond. But imagine if you have rain, it will spoil the salinity gradient again. So therefore, you can see this system is not used a lot in the tropics. Because remember, we have 176 rainy days, which is a tolakah from the bottom. Yeah? I have to answer a question from a reporter before saying that the Malaysian weather is diffuse, so solar is not useful. But I reply back to him, it's the best thing that happened to the tropics, because it acts as a natural cleansing mechanism to your solar collector. Otherwise, your solar collector becomes rusty. And in terms of energy yield, it's better than even some of the arid region, because the arid region a lot of dust, and dust, mind you, there are what do you call it? It will degrade your performance by 50%. I have a PhD student who looks into 32 types of dust to look into the effect on the performance of it. Solar steel is actually the production of fresh water from either brackish water or seawater. Basic principle is same. You can also use nanofluids in that. And a special type of collector is known as a photovoltaic thermal collector. Photovoltaic collector, or the collector that you see, the collector that produces electricity, right? It is made from semiconductor material. And that semiconductor material depends on the temperature. The lower the temperature, the better the performance. So in mechanical engineering, one of the things is that if you can do a lot of cooling to something, so you're going to have performance which is much more superior. Imagine that photovoltaic collector will give you more power more in energy because you cool down the collector with nanofluids. In terms of disadvantage, the disadvantage of having nanoparticles in fluids is stability. But there are other advantages too. The advantage is that you can adjust the property, you can adjust the thermal property, you can improve the thermal property, you have high specific area, you reduce the pumping power to achieve the equivalent heat transfer. So therefore, there are many methods, many ways for you to increase the stability. And this field there's a lot of interesting research going on in this, and I would like to, at the end of my session, I would like to share how can you start heat transfer. Your heat transfer lab can be converted into a solar thermal lab. Okay? There are physical methods. For example, magnetic steering will do the stability job. Higher shear steering or ultrasonic bath can do it. A homogenizer can do it. Or you can use chemical method, which is, for example, separator, pH control, or surface modification of the nanoparticles. Nanoparticles, now, you can start anywhere. You can go to the, starting from the metal base, and the metals are, for example, metals and metal oxide. Then you have carbon base, for example, the fullerenes, and the carbon nanotubes and the graphenes. You can also look into nanocomposite, namely ceramic materials, metal matrix, and polymetrics. I have looked at many PhD theses looking into nanocomposite to cool down PV panels. And as an overall picture of this, I'm not going to go too deep into it. But looking into all of this, for the Google, for the there are still good pictures. For the Google, I don't know, something happened to the company, they're not very,
not very sharp.
So here you can see some of the candidate materials, candidate nanoparticles to be used in nanofluids for the solar thermal collectors. And the bottom part are all the diagrams that we have done in our lab to look into the SEM profile pictures of those nanomaterials. I'm not a material guy. When I see this, I just see work. I didn't see anything. Yeah? But for us, mechanical engineers, we look into the heat transfer aspect. We look into the second law aspect of it. We look into how we can use it essentially to reduce wastage, to use using the nanoparticles. And now looking into hybrid nanoparticles. It means that you can mix around all of that. You can mix with the metal base. You can mix them up. But don't overmix it. You will not do good. Sometimes you will do bad. And one thing about it is that nanoparticle has expiry date. So, yeah. So better use it when you got it. Because we were under lockdown for nearly a year. So when our students want to start our research again, they found that the nanoparticles are expired. So they are expiry period. So it's very expensive, So it's a simple process in nanofluids. It can be used for any sort of heat exchangers. And of course, solar thermal collector is a heat exchanger. What is important basically is environment friendly, low cost, and there is availability for it. There are some nanoparticles very exotic, so don't go for that. Go for the simple. For example, the silicon carbide, very easy to get. You can also make your own nanoparticle, synthesize your own nanoparticle. And then it has to have a base fluid. The base fluid is either water, refrigerant, ethylene glycol, or even thermal. These are heat transfer fluid. And with this combination will give you the environment-friendly, safety, and with cost-effective. And there are two methods that we use to prepare nanofluids. You can always use these two methods. Number one, you can have you mix the nanoparticle, you do the ultra solidification, and then you add some surfactant to have stability. When you see that nanofluid becomes clear again in 2 days, that this is not good. So you need to put some surfactant into it. Or a single step method whereby when you mix all of them, you can get the nanofluid. There's no two-step method to it. And as far as the heat transfer performance in nanofluids in solar energy system is concerned, these are the properties and these are the interrelationship between the properties as well as the nanoparticle parameters. For example, the properties is like density. You can play around with it. You can modify. You can modify the specific heat. You can modify the thermal conductivity. You can modify the viscosity. And this has a significant contribution to the heat transfer performance. And the nanoparticles parameter that you need to look into is the material type, the concentration, the size, the shape, the type, and what additive you use for it. Now I'm going to go in. That is the introduction to solar thermal, and I have given to you what the main point that I want to here is that you have to understand the tropics before you start a program on solar thermal. At the end of the day, people will there are many people who try to introduce technology that doesn't work here, and at the end of the day, the solar technology get the bad name. But actually, it has to do with the weather. It has to do with what is suitable for the tropics. For example, that also goes into when you are designing building, looking into cooling, passive cooling of a building. So that really you have to look into the characteristics of the. I will start with solar drying system. One of the most, I think, one of the interesting application of solar thermal. This is a dryer that we have in our solar park before. Now, only what we dry is agricultural and marine products, because we need to increase the shelf life. We need to increase also the quality of the product, because this product, when you increase the quality, you increase the shelf life, the cost also is very very lucrative. And some of the product you can maintain the essential ingredient in terms of vitamin and so forth. For example, medicinal herbs. For example, in medicinal herbs, you don't just dry like that. You just dry, you become hampir lah. So you need to maintain some of the essential ingredient in that. And of course, drying, before you start drying things, you need to look at the drying curve. You need to look at the drying characteristics of that. For example, if you want to dry tea, make sure don't dry the tea until 100% dry. Then what you have is just fibrous, fiber material. You need to dry until about 50% moisture on dry basis, so that you can get the essential ingredient in the tea. Now, if you look at commodity, for example, paddy, the present method of drying, what are the energy resource and what are the drying time, these are shown in this particular slide. So therefore, when you look at this, you can find what are the can you use solar thermal to assist in terms of drying, to assist in terms of preservation of that, increasing the shelf life, so that you can keep for 3 years in your store and then sell it for the next year and then so forth. Paddy, cocoa, coffee, pepper. And pepper there are two, white pepper, black pepper. I think from now you know what's the difference between black pepper and white pepper. It takes 7 days to dry the black pepper and 3 days to dry the white pepper. You know why? I think satu tu dia masuk dalam air, dia kena rendam. Yang satu lagi tu macam tu je. So, and then this is tobacco. Tobacco is not called drying, it's called curing. I was approached by a company, Philip Morris, to dry some of this. And then if you look at the tobacco, it says that dangerous for your health. What if you say it is dried by environment friendly solar dryer? I asked the Philip Morris guy, he said, even me, I won't give my children to smoke. Okay, and then you have tea, banana. In some culture, banana are dried whole banana. And then you have anchovies and seaweeds. Interesting is the seaweeds. The picture that I showed you earlier in my introduction slide is a seaweed dryer in summer. It requires 13 days to dry seaweeds. And then it only requires maybe 3 or 4 days using the solar dryer. So you have, and the price is expensive. So therefore you have, another important thing for using solar dryer is that you increase the throughput. Because kalau you dry pakai biasa je, sikit sangat yang keluar. But if you have dryer, a nice dryer, you can increase your throughput. It means that you can calculate your payback period. There is another dry thing that in Bido, Perak, they dry this particular clay or kaolin. And I think companies like Chanel do buy this for their cosmetic product. And then you have this smoked banana. There are this picture is taken probably 30 years ago. The guy who was taking that particular reading is actually Professor Muhammad Nur Dalibi, now retired professor, used to be Vice Chancellor at Sabah, UKM staff before. And there are, in some culture, the banana need to be smoked, smoked banana. I've had some smoked banana which is from Thailand. Nice packaging and said this product is dried by environment friendly solar dryer. So the price from 10 ringgit becomes 50 ringgit, because you use an environment friendly solar dryer. And this is tobacco curing. The reason for tobacco curing, why it is called tobacco curing, because it is not at only one temperature, it's a different temperature with time. So therefore we call it tobacco curing. Tapi it's a drying process actually. And then you have the oil palm fronds, which is actually used for animal feedstock. And this is one of the, I was assigned a project by UNIDO for a solar dryer in Cambodia. So I visited many places. One of the places, and I later recommended this particular site to have the solar dryer because the product costed, and also this product, the dried product is $10 USD per kilo. Jadi kalau tinggi bagus lah. That's why if you want to dry herba, it's good. Okay, very good. You can get 6-month payback period for this. So this is a dried fish in Cambodia, and again, it is subjected to a lot of control in terms of quality, insect infestation, product deterioration, and so forth. This particular dryer is a dryer for, this is called a tunnel dryer. It works it works like a convective dryer. But we put a small PV panel there so that it can have a small DC pump to have air intake into the. This particular program was done in Kampung Karang Asam, Kelantan, Indonesia. Aku masa bagi ucapan itu silap Kampung Karang Asam. Dia orang faham betul. So it's part. You can also use this part of your social CSR project. Yeah? So with just 1,000 ringgit, they can make this product and use this for drying of some of their products from the village. You can use this. For example, this is in the internet. You can just use the design. Now, what is a solar collector? Basically, okay, where the innovation in the solar collector comes from. In the solar dryer, the component is very simple. You have a solar collector, and then you have a fan, and you have a drying chamber. The heater is optional. If you want to do research, you need the heater because you want to know how much % is given by solar, how much is given by other resource of energy, other energy resource, by the auxiliary. The innovation in solar collector comes in in solar drying system comes in two forms. Number one, the solar collector itself, and number two, the drying chamber. But the drying chamber tu tak banyak sangat because dah ada dua jenis. I mean, there's a cabinet type, there's a bed type. That's not much. The next is innovation in terms of from the fan to the drying chamber in terms of the distributor plate. You want to distribute all the air uniformly throughout. But that pun has been done a lot. So therefore, the solar collector itself, when I first started this research in the 80s, until now, I thought that it's going to be saturated in terms of the design, but it's not. You can see in general, there are a lot of new innovation and new design in terms of the solar collector. The whole idea is that you have to increase the heat transfer. Increasing the heat transfer means that you have to increase the collector area. So there are many ways of increasing. You have double pass, you have corrugated, you put fins in the absorber to increase the area. And also, how to distribute that in an array so that you can have modules. For example, if you want to dry, let's say 10 kilo or even 100 kilos of dry products, you have to understand that what product to be dried. Then you understand that how much time is required to dry it. And also, in addition to that, you know how much of this collector to be used. So, besides looking into collector configuration, how to connect them in modules is another example that is shown in this particular diagram. So, for example, we take one of this, and then for example, this is an example of a collector which has double pass and has fins in it. So you can see when you have fins, you increase the heat transfer, you increase the absorber area. When you increase the absorber area, you increase the efficiency. Because why? The absorber area become cold. Where does the air go? Goes into the outlet. Yeah? But if your collector you design yang absorber tu panas gila-gila, so it's not going anywhere. Right? So it's a bad design. Bad design. Yeah. So some people use even triple pass, but triple pass tu masalah lagi. This double pass, and then you can redesign that and also use even double chamber, triple chamber. Yeah. So it depends on what you want to try. For example, this is the double chamber. Now we look into a triple. Yeah. So you can see here how the interconnection is done with this. And then here is one of the other four chamber, which uses the double pass collector. And then you try to connect them. When I first designed this, it's quite impossible to do. Kalau one pass nak macam tu, kalau double pass tu how to do it? The idea comes from where? The idea comes from the fuel cell punya stack punya flow. Open it up, I got the idea. So we connect all the double pass into units, into several units, and it depends on what you want to dry, you can use this. Now, I'm glad to say this collector is installed in Kuantan by one of my students, Zafri. Zafri is there with his colleague dengan dalam team tu. We have to have two, because of this collector kita ada dua connection. And then this is in Kuantan. Okay, you look at that groove there. If it's straight, collector area dia kurang. Kalau you have groove, collector area dia banyak. So this is how one way of increasing the heat transfer. Now, if you want to do a groove that looks like a curve, fine. If you want to have something that has tripod yang macam itu pun, fine. You can. The design is your design. Your design. But the idea is that if you can increase the absorber area, you get more heat. And that particular, yang pentingnya that absorber dipanggil itu, suhu dia rendah. When it goes to the drying chamber. This is a solar dryer untuk Roselle. The manufacturer bought a 300,000 ringgit dryer for the Roselle. Doesn't work, so we come to us, we dry for her. The Roselle. So these are the Prof. This is another dryer that we installed in Cambodia from the UNIDO project. It is actually it's a V-groove dryer and a double pass. So this is the product that they drive. This product that they drive is actually ikan dried fish from the Mekong River. One thing that you have to follow the rules. It's okay for the collector to be any material, but for the drying chamber, mesti stainless steel. This is a standard for food product. Kita boleh beli. Okay, ini ikan keli. Ikan keli ni janganlah buat, susah nak clean. Ikan keli kan macam susah nak clean. Kalau ikan keli ni buat benda lain lah, clean pakai cara lain. Tapi boleh, You design proper the dryer, you boleh buat. Now, ini balik pada Cambodia tadi tu. So, this is a product we dried for them, very nice. Before that, the product looks like that, with the fungus and everything because it's open dry. Problem is that when we try to sell it, they prefer the product with the fungus. So, belajar, jadi belajar. No problem, I can introduce the fungus. But clean fungus lah. This is a project in Pontian. CIMB ada satu kaum orang asli yang duduk tepi pantai. So dia orang dry ikan belanak. So very rich community ikan belanak ni yang kita beli dekat pasar kita ikan belanak. I think kau pernah pergi sini kan tengok benda ni di Pontian. Now let's look into some of the costs for dryer. These are the costs lah sampai dalam catat ni dalam ringgit Malaysia. Dalam ringgit Malaysia USD. And then these are all the things that you need. Now if you look into the payback period in some of the payback period to less than 1.5 years. In some instances, this is less than even 6 months. Tengok pada produk yang dry. Kalau you dry herba, which the cost is high, it means that you can get your payback period less than 1 year. I mentioned before, this is seaweed dekat Sabah, and you look into the product. When you dry the product, that dried product can be used to various other commercial product. In fact, katanya dalam ubat gigi kan ada xanthan, kan? Xanthan also is derived from this. So it is very saya rasa about 28 ringgit or something per. I'm not sure about the price, but it's very. So how they do it is because if you look at this, they use a float and then to cultivate this species. Species tak ada dekat sini, species hanya dekat Sabah. Species dan jenis. And then you cultivate it, send it by this boat, and then this is the old process of drying. All processor drying require about 13 days tadi lah. And then kita dry pakai our dryer ni. And then this is the dryer kan, yang boleh letakkan PC. So the point that it has to be dried on platforms. Dekat platform dia macam. So therefore you can see that solar dryer play an effective for this. We have another type of dryer here. This is a greenhouse dryer. It's not very successful sangat. It's green dryer. But I think it's other, it's just other design hilap sikit lah. And then another type of dryer is the heat pump dryer. I think for mechanical engineers, you look at what is a heat pump. Heat pump is actually a refrigerator. In a refrigerator system, you have 4 components. Dekat luar tu condenser, and then you have the evaporator dalam ni kan, yang sejuk. And then you have the compressor yang bising kan. And then there's of course in between the expansion valve. If you want to use the refrigerator as a cooling, so you use the evaporator cooling. You throw the heat out. In this case, we want to use it for drying. So what do? We will run air to the evaporator. Humid air, lalu dekat evaporator. Like you can see from this diagram, may warna biru. When you run it through the evaporator, it will steal the water. It will get the water, jadikan dia bentuk liquid. The water vapor dalam air. So after the evaporator, the air that going to go into your system will be dry air. Because in air, there is certain percentage of water vapor. You can control the water vapor by temperature. The temperature in the evaporator is cold. So it will take the water vapor out from the air before it enters the condenser, which is already hot. Jadi hot, after the condenser, you have hot air and dry. So pergi ke collector, lagi tinggi but dry. Then goes into the drying chamber as dry, hot, non-humid air. So it means that your product within hours can be dried and in perfect condition. Dia tak hancur dan sebagainya. So this is the one of the I think the best application if you want to use dried. The product can be dried within certain shorter time, and also the product can the quality of product is very good. And tadi kalau yang keli tadi boleh lah try tengok. Yang keli minyak banyak tu masalah. So, and of course you have various modes. You can use this. Kalau yang this mode, it means that it's just the one before. No heat pump. Tadi, now if you want to use both modes pun okay. Only the heat pump mode pun is okay. So this is the only the heat pump mode. We have dried stevia. We have dried stevia, and in stevia, the product ni is about RM100 sekilo, something like that. So it means that this dryer, kalau if you happen to buy, within 6 months you dapat balik modal. So it depends on the product that you want to dry. You can see the color dalam stevia tu pun tak brown, so it maintains the color. So I would like to show you a project that we have in one of the orang asli community in Pahang, in Tasik Chini, where we call it a net neutral community. It means that the electricity is supplied by PV, and also the drying for their forest product, for example, Kacik Fatimah and also Tongkat Ali, is done by solar dryer. Okay. So, ini dekat apa tu kasut sini. And this is the product that ini adalah dryer dia. Ini lagi sikit. So, ini untuk batin ya. Jadi I think in this particular place about 5 families.
Ni Ongkak Ali, Cik Fatimah.
Aku tak tahu macam apa lah. So,
but in this case, it doesn't require any electricity semua.
pakai PV. Dia lah benda yang dia buat.
Orang asli modern.
Okey. Dia orang masih tengok. Dia orang tak boleh. Baru tak boleh. The next is solar water heating system. Just to tengok apa beza dia. Yang ini nama dia evacuated tube. Evacuated tube system has a condenser at one of the tip. So it means that all the heat will be transferred into that condenser. And from that condenser, you will be running a working fluid. And you can use also nano fluid within that system. So this is called evacuated tube solar collector. And the other type is a flat plate collector. Flat plate is very simple design. It has 4 components: the glass cover, the absorber, the insulator, and the container. So what are the research in the field? The research in the field are actually looking into material that to be used as a selective surface for the absorber. They absorb more, and of course also the use of nanofluids. This is an active system, macam tadi active system. You have now a passive system, and you tengok dekat, this is a passive system. The passive system consists of 2 separate tanks, the tank and the collector. Because when that collector is heated, hot water will rise to the tank, and then from the tank you'll be using that for your applications. And then you have also swimming pool. Now swimming pool ni dia tak pakai with the glaze, dia unglaze. Sebab apa ni swimming pool bukan nak sampai 50, tak. Jadi spa. Swimming pool ni you want to be between 30 degrees temperature. It's just enough for you to get in. And another project that we have is this one in this particular solar water heating system in Hospital Universiti Bangsa Malaysia. So we have this system located in this particular site. Then we did the schedule formation calculation, and finally the design here. So this also you can apply that to many systems. Okay. And then you can see that there is a reduction in terms of the annual LPG usage for the system. And if you look at this particular diagram, you can see the percentage savings. The savings is about maybe 70% by using LPG. This desalination system adalah sistem yang gunakan, you try to generate fresh water from brackish or from salt water. Ada yang jenis terapung-terapung macam ni pun ada. So this is another one. I think this is in India. Dia ada orang gunakan. And then next we will look into aircon. Saya akan go through this aircon sekejap topik ni, aircon system. Now, if you look into the aircon, these are the candidate cycle for aircon. Desiccant, ejector, Rankine, absorption, chemical, thermoelectric, vapor compression, and now if you look into the 2 type of collector, one uses one system, and one uses heat, the other one uses electricity. Electricity is important. This is called a vapor compression cycle. You just put lattice into the condenser, habis cerita. Masalahnya, the current in that PV collector tak tinggi sangat. So you need to have a special type of, now they sell DC refrigerator. So that DC refrigerator refers to using the photovoltaic panel. But for the thermal collector, it's different. It's using thermal energy to create cooling. And the candidate for that are listed. Desiccant, ejector, Rankine, absorption, and so on. And the application is from freezing to food vaccine storage to air conditioning system yang sekarang ni. These are the application with the various temperatures. So now the simple system is system that looks like this. You have the vapor compression, and then what you do is that you use the photovoltaic panel that produce electricity. That's true, yeah. And then what you do? You calculate the COP, kan? And then what is the COP? Is the desired output over the desired input, and then you dapat dia punya ni. And then you have another cycle called the absorption cycle. Apa yang berlaku dalam cycle ni adalah you have two material yang berbeza. You ada satu dalam bentuk liquid, satu dalam bentuk gas. The generator will consist of these two fluid. For example, dalam generator tu ada campuran mixture of ammonia and water. Ammonia and water ni dia saling suka cinta sama dia. Ya? Tetapi yang boleh memisahkan dia haba. Haba pada 80 aja. So that's why it is good that you use evacuated tubes ke apa, sebab dia suhu dia lebih daripada 80. And then when you know that when you mix water with some other impurities here being ammonia, the boiling temperature will go down. So what happened? One becomes vapor and the other becomes liquid. So they separate. The ammonia will go to the condenser, go to the process sama macam proses the vapor compression, but at the end of the day, they will meet back with water. The endothermic reaction will happen. Dia jumpa balik kawan lama dia ada affinity to water, dan dia jadi sejuk. So this process, you continuous heat, continuous supply the heat to the generator, you have continuous continuous cooling. So this is a basic absorption cycle. You gunakan ciri-ciri satu solution yang suka, kemudian you pisahkan dia, kemudian dia sambung balik, dari sambung balik dia sejuk. And continuous. Itu dia panggil absorption. Yang memisahkan hanya haba. So about 80, 70, 80 dia dah berpisah. Ada satu lagi dipanggil lithium bromide water. Pun sama ni. Tapi daripada nama dia tahu lah, lithium bromide, ammonia, very apa ni? Very apa tu lah, apa ni? Agak dia tak bahaya, tapi dia susah nak handle. Tapi you can handle it, tak ada masalah. The COP will go up because why? The desired output becomes higher and the input to become lower. You can have various innovation in terms of you can put an ejector that will increase the efficiency. So you can see research in aircon banyak sekitar trying to increase the efficiency. Kita panggil COP, and we add a lot of items into it, basically to enhance the efficiency. So in this case, the efficiency goes up, and then we have another thing that we did to it. We put a flash tank. Ada juga yang kita buat, kita akan letakkan ejector sekali lagi, and then we have multiple generators. We increase the efficiency, and then with this you can see Diagram ni biasa you tengok the temperature and the COP with the basic system in the injector and the flash tank. So we did this experiment before. This is a double flash tank. So kita buat double ejector, and here are some of the experiment that we did before, just to show you this. We even add 3 ejectors, find out that only 2 is okay, 3 tu tak payah pun tak apa. And then you can see the result from it. You can see the increase in the COP when you use the 2 ejector. Now we can see here that from here you can see the temperature of that evaporator tu dalam 12. So it's okay lah. You can get. And then here is okay. Another system is called a Desiccant System. Saya akan go through sekejap ni Desiccant System ni. Okay. There are 2 type of Desiccant System, satu liquid, satu solid. Now, apa dia sebenarnya kita nak tengok Now, have you seen this diagram before? This is called a Psychometric Chart. Where you are in the Psychometric Chart will tell you whether you're comfortable or not. Okay. You are comfortable with 3 things. If you know the temperature, if you know the humidity, and if you know is that air movement. Macam dalam bilik ni. Do I feel cold? Do I feel comfortable? No. Sejuk sangat. Then I need something else. I need movement of air. So, this particular yang you belajar dalam kursus thermodynamics dulu is called a psychometric chart. It's actually knowing many of the properties. In terms of humidity saja ada 2 property dalam dia kan. Satu dipanggil specific humidity, satu dipanggil relative humidity. Relative humidity itu kalau 100 maksudnya dah tak boleh dah. Jalan sikit dia akan peluh. Kalau humidity kita kat luar sekarang 90 kan. You pergi sana, you berjalan sikit je, you punya liquid dalam body dia terbuat. Apa aku nak pergi keluar? Baik aku stuck dekat kulit aja. That's why you rasa apa ni. Tapi kalau you kat Mekah ke apa yang humidity, relative humidity dia 40, tak mana pergi air peluh ni. Dia pergi ke udara. Lepas tu you lupa nak minum, you rasa dahaga lah, rasa tu lah. Dia sebab selalu pergi Mekah tu orang tu ni start minum banyak kan, sebab because the air tu dah bukan saturated. Sini air dah saturated, So in this case, in this type of solar cooling system is to play with the air dalam bilik. How do we do that? This diagram, kalau you ada beberapa properties, ada dry bulb temperature, ada wet bulb temperature. Dry bulb tu yang you the temperature that you baca pada any thermometer, itu dry bulb. Why wet bulb? Because kalau you basahkan dia, then you know dia dalam 100 relative humidity. Itu reason dia. That's why we have kita ada yang swing, tak ada? Kita letak sikit, kita letakkan kapas basah dan kita buat gini. Dan itu kita tahu itu dia punya wet bulb. Pertemuan wet bulb dengan itu dalam ni adalah 100% saturated line. Okay. Sorry kena siapa yang buat manufacturing ke aerospace ke sikit problem lah ni. Thermodynamics saya boleh faham. Hari ni kan ngajar benda ni. Now, if I increase that specific humidity. Specific humidity, it means kandungan air. Betul-betul, really. It means that kalau relative humidity means that potensi untuk itu but specific humidity ni memang kandungan air betul. Amount of water per amount of dry air, itu maksudnya. Relative humidity ni 100 maksudnya tepu. Kosong maksudnya depan tu jangan pergi kawasan tu, jadi desiccant macam you masuk kering tu, jadikan kering tu kalau masuk dalam kawasan. So now kalau saya start proses saya constant temperature, pergi ke atas, it means that I akan proses dia dipanggil humidification. That means I macam yang dekat kedai mamak tu kan, dia taruh tu kan, dia taruh. Itu dipanggil humidification. If I'm going to go down, it means apa dia? Dehumidification. Dehumidification. Saya buang dia punya tu. Only can be done through desiccant dia. You letak desiccant dalam mana-mana, itu dia bahan yang akan ambil benda. And then you have process di mana temperature di increase, pelik sikit ya, temperature increase ke sana ni. Untuk psychometric chart. And then itu dipanggil, temperature decrease sana, cooling ya. And then temperature increase dipanggil heating. So these are the four process yang perlu ada dalam mana-mana bilik ni kalau kita nak convert. Ya. Dan bila kita nak convert, kita akan, contohnya, kita akan di sini, kita akan cooling dan dehumidify. Kalau bilik ni tak dehumidify, banyak sangat air dalam bilik ni, banyak sangat water vapor, you don't feel comfortable. So, it means that you are going to go into a comfort region, dalam region itu. How do you know this is a comfort region? It has been done by X-ray, dan inilah dia, from the interview, you feel comfortable if you are in this region. It means that if you are the tropic, you try to cool and you try to dehumidify. Itu sebabnya kadang-kadang kita pergi ke hotel-hotel, dia make sure yang suhu dia betul-betul rendah supaya moisture tu tak timbul dekat mana-mana merosakkan barang dia. Jadi apa kita buat? Kita pakai coat lah dalam hotel kan. Kan? Sebab itu dia sebenarnya kat hotel tu nak save barang-barang dia, bukan nak save kita kan. Tetapi kalau kita di rumah, takkan kita dapat macam tu. So kita akan cari region-region yang sepatutnya 24 degrees C, bukannya 18, 24, dan kita dah rasa comfortable. How? You pergi kepada you punya sistem tu, bukankah ada mode dia, ada mode yang macam ice, mode yang macam dew. Pergi mode dew tu. Mode dew dah pergi 24. You feel comfortable because why? Dia dah take off you punya humidity dalam tu. That take care. Yeah? So these are the science behind the second type of cooling system. Because of that, dia tak ada chemical, tak ada apa dah. It's just playing with the air punya properties. So what we do? Okay. So this is how it looks like. So what we do is that, perhatikan ya. From 1, 2, 3, 4, 5, 6, 7, 8, 9, kan? You only need a temperature of 70 degrees yang kat warna merah. Where do you get it from? From solar collector, right? Because itu candidate. You nak pakai waste heat pun boleh, tak ada masalah. Now, it has 2 desiccant wheel, it has 1 desiccant wheel and 1 heat exchanger. From 1 to 2 to 3 to 4, and then bila 4 dia dah sampai ke rumah. 4 it goes into the room with air being conditioned at a very nice temperature and humidity. How do you do it? You have to get rid of the humidity. You have to also decrease the temperature. You need in the process, kalau paling senang sekali kita tunjuk dalam bentuk diagram itu kolektor dia, matahari dia. Okey, kita tengok dia punya. Perhatikan satu di luar kan. Satu tu suhu mungkin 32 dan humidity dalam 80 lebih kurang. Satu, kadang satu. Apa saya buat? Saya pergi kedua. Apa dia proses 1, 2 tu? Proses itu pembuangan air dengan pemanasan. Betul? Somehow saya daripada 1 ke 2 tu, desiccant wheel tu akan buangkan air. Desiccant wheel. Dia akan buangkan air daripada 1 ke 2. Yang dekat bawah tu kan. Kemudian daripada 2 ke 3 adalah proses penyejukan. Tetapi ada air dibuang tak? Tak ada. Dia buang begitu je. And then daripada 3 ke 4, saya akan tambah sikit air. Jadi sejuk. Masuk dalam rumah. Dia masuk dalam rumah, you duduk, you rasa comfortable dalam rumah, kemudian dia keluar. Daripada 5 kepada 6. Sebenarnya 5 kepada 6 tu ada tambahan air. So 5 ke 6, bila tambah air dia pergi ke mana? Dia pergi ke 100% punya. But you don't have to worry. You are not there. You are in the room. You are at 4. Tetapi I'm going to help my other friend, right? And then from 6 to 7 is a process of heating with no addition of any form of water. From 7 to 8, my collector play. And then go to 9. Tetapi kan orang tak buat macam tu. Orang recycle balik. Bukan senang nak dapat that air tu. Yeah? But what happened at 8 to 9 actually, desiccant tu recycle balik. regenerate balik. Sorry, the word is regenerate, bukan recycle. Regenerate balik. Because dia dah basah. So we regenerate balik. And this process repeat itself. This is called a desiccant cooling system. Desiccant cooling system. And then this is the experimental result that we have. If you look into this is how it looks like. It doesn't have any chemicals in it. It's just mechanical system in it. Dan saya cadangkanlah kalau you nak involve dalam solar cooling ni, look into this system, because this is why I did this here. A lot of simulation work we do, and then you look at this, kita tukar macam-macam dalam ni desiccant dia, and then what I just show the result, and then here shows you that ada one stage ventilation, one stage recirculation, two stage ventilation, two stage. Mana you nak? Kalau you nak solar fraction tinggi or COP tinggi. Kadang-kadang tak guna pun kalau solar contribution dia tinggi, kalau COP dia rendah buat apa? Kan? So, kita daripada sini kita tengok yang paling best sekali sini dengan COP yang paling tinggi sekali, pemenangnya adalah two stage ventilation. Ini belum ada orang buat lagi sebab ni baru simulation Jadi kalau siapa nak apply for grant boleh apply Okey. Satu lagi adalah dipanggil liquid desiccant. Tadi desiccant solid. Ini desiccant dia liquid. So the process of dehumidification tadi dilakukan dengan dia melalui a liquid form of desiccant, not a solid form. So therefore dalam proses ni dia tak perlu ada macam yang tadi tu kena regenerate balik dan sebagainya. It goes through this process. And then we have done a simple experiment on this. Ini how it looks like. So kita tengok ni the idea is that to tumbuhkan orchid daripada Cameron Highland, because kita nak duplicate suhu dari Cameron Highland dalam ni, which is 23 degrees C dengan relative humidity yang rendah, buat 60. We cannot achieve here, betul tu. So we try to buat orchid dekat sini, tanam orchid. Okay, tak apa, tu cerita lama. Okay. Now, the next type of collector is called photovoltaic thermal collector. Now, normally you can see kan yang thermal collector tu dengan tu, because they are separate function. One produces hot water, the other produces electricity. So what we do now is that kita combine kan jadi satu. Because why? Daripada segi diagram ni kan, you can look at yang warna biru tu, itu limit untuk PV. Dia tak boleh lebih daripada itu lagi. Buat macam mana sekali pun? You can, but you have to put more exotic material dan sampai 40%, but then the cost will be like maybe more to it. But as mechanical engineer or engineers per se, we look into this, there are a lot of things wasted. 70% is just converted to heat saja. So why don't we take that 70%, do something good to it? Bila kita dapat take that 70% out of it and go for some thermal processes, that collector akan jadi sejuk. So dia akan increase dia punya efficiency. Yang 10% reflected tu, you cannot do anything with it. It is waste. You can use, you can do something, for example, to avoid more reflection. Boleh buat, ada. Dipanggil selective surface. So, but these are the energy balance for that. 20% is by the PV panel, 70% loss SE. Itu opportunity kita lah. So, therefore, we introduce a type of collector which is known as a photovoltaic thermal collector, which utilize that heat. Either you utilize the heat for many other processes, for example, for heat pump ke apa ke semua, for drying ke apa, atau in the same time you cool down the PV panel, and that cooling down of the PV panel will increase the efficiency. Now, ini adalah contoh di mana kalau you letak saja PV panel dekat atas rumah, you will get about 50 degrees. So, what you can do is actually to design a good absorber underneath it. You can use CFD package, you can use all your knowledge on heat transfer to basically cool down and wet the surface. Maximum wetted surface kita panggil. You can look at that CFD diagram macam mana kita wet the surface using a simple serpentine type. You can use many types, parallel flow, spiral flow. Yang the best thing is that you can try to cool down. Macam contohnya one of our student did that, the design yang actually is a combination of yang sekolah tu kan, a combination of many. But be aware one thing, pressure drop dia akan naik. So kadang-kadang bila pressure drop naik, tapi energy that you get is a lot, why not? You can do the you can do the techno-economics. Yeah? Okay. Satu lagi adalah just to give you this, when you have the thing separately, you will have electricity banyak tu je, tetapi thermal banyak. Tetapi bila you combine, the electricity tu dia tinggi. So therefore, there is advantage of using it, and it's not used here. It's also used in this particular area in the Swiss. Yeah? And also in some of other areas in Europe, yeah? Basically to produce both electricity as well as thermal energy. You can use it also for cooling of PV panels supaya more electricity go to the grid. Dalam case ni, you pull it down. Bila you pull the thing down, and then you can look into ways to increase the efficiency. Ini contoh dia, dalam tu kita ada macam-macam design and now you can introduce nanofluids into this. When you introduce nanofluids, you can see a different in terms of the, kalau blue color tu maksudnya sejuk kan. So here where the advantage is when you use nanofluid. Not only that, ada lagi benda you boleh introduce. You will need to mix the nanofluid within this. Sama ada silicon oxide, silicon carbide ke titanium oxide. You can use this and you can measure the density, the viscosity and the thermal conductivity and so forth. Okay. Now, what is this is a simple diagram, but no need to mungkin ada yang pertama kali tengok diagram ni. Tapi this is called NIV curve. Terus saya fikir banyak-banyak. Tengok pada PVT water tu 80.6. Satu panel tu 86. Tengok pada PVT campur dengan silicon tu. Berapa banyak beza? Because why? The nanofluid play a role. Yeah? So it is about maybe 30% increase. Yeah? This diagram shows you that increase in power because you put the nanoparticles in it, nanofluid. And then there's another design that encapsulate that nanofluid punya tube tu in a PCM. When you do that, dia boleh lagi increase the efficiency. Yeah? So inilah cara dia orang buat cara dia buat nanofluid. So therefore you can look at this simple daripada jauh sama macam kolektor biasa, tapi dia ada that package of PCM and also nanofluid within the system. It looks like any ordinary system. From the first generation, the combined PVT efficiency about 60%. Ini combined PVT efficiency from the first law of thermodynamics. Ini combine bukan maksudnya combine elektrik dan juga sebab dia tinggi. And then the second generation dengan water saja with nanofluid is about 74. But when you have the incorporation of the nano PCM, you have 85. We are trying to go into more than the 90s percent. Now, if you look at this, from a 60 watt panel becomes a 119. It means 50% increase, almost a double increase in the performance. Jadi lebih banyak lagi digunakan. In the literature, dia yang paling best sekali. Tapi tak tahulah mungkin sekarang orang ambil alih-alih. And finally, kalau kita tengok that diagram sini, conventional grid connector, kalau you ada PV panel letak dekat atas bumbung you, within 15 years dapat balik modal you. Oh itulah, tak ada apa-apa dah. Tapi cuba you try to decrease that. Satu cara dia adalah apa dipanggil sebagai feed-in tarif program. Maksudnya ini adalah program kerajaan di mana dia bagi you subsidi. So dia bagi you peluang untuk jual pada orang dengan harga yang lebih tinggi lagi. Dia beli dengan harga yang lebih tinggi lagi. Selalunya 4 kali ganda. Jadi you punya payback period jadi dalam 6-7 tahun lah. Tapi itu subsidi. Sebab bila tak bagi subsidi? Sebab nanti you punya electric bill increase. Sebab apa? Dia ambil pada duit you, bukannya duit dia. Kan? So that's why you can see that during the introduction of feed-in tarif dulu, ada increase in your electricity bill sebab nak bayar orang yang, tapi tujuannya menggalakkan penggunaan. Tapi program tu dah habis sekarang ni. Now, without subsidy, kalau you pakai yang lain-lain tu, yang with nanofluid, with PCM sebagainya, you don't need to have that subsidy. Because that collector itself will produce a lot of power. In case you tengok banyak yang dekat dalam rata-rata ni kan, dia decrease with time. Now, this is the opportunity for you basically to nak naikkan yield dia balik dengan letak nanofluids ke apa ke belakang dia, supaya you can increase the you will cool the panel and you will have the energy gain. Okay? Itu cara dia. Okay. Ada banyak cara lain lagi. For people interested in aerodynamics, jet impeachment is one of it. Jet impeachment will basically increase the efficiency of the panel. And of course lah, with this there are challenges and so forth. Okay, I sekarang pergi yang last kali, because time dah ni. How do you, semua yang hadir pada hari ni, how do you want to start the solar lab? Because I think, especially solar thermal lab, how do you want to start? Number one, you start dengan software. There are a few software that you can be part of your a few software that you can use, and you can model any solar thermal system that you want. The software is Transys. You have a cracked version of it, tapi kalau cracked version you tak boleh publish. Tapi kalau letak nama kami dalam tu boleh lah, sebab kami ada license dia. Tapi dia tak mahal sangat, and the license is perpetual. So try to get this software and try to get the student to play with it, because you can model anything. You can model Desiccant System, you can model absorption system, you can model even adsorption system. You can model a lot of things. Katakanlah, let's say you want to do a solar thermal system for hospital. You put your time into it, design it, and then use the Malaysian data, and then you can do a lot of output. You can even publish paper. So start with this. So these are some of the software, but there are also other software that you can try to do, but the thing is the cost. But you can always, for example, IES, you can always katakanlah if you have architecture department, because architecture department dia tengok pada bangunan. But in IES, there is also software to include solar in it. So kalau tak guna tak seronok lah benda tu. And of course there is Homo Pro. Homo Pro ni look into optimization of energy microsystem lah. But this is number one. Number one, that kalau when I was in University of Wisconsin in the 80s, the rank of the department is number one. But the lab dia tu satu bilik je. For this particular but because they do a lot of simulation and they develop the Transys. So Transys means transient simulation system. Not only for solar, you can also use for other thermal system sekarang ni, because the Transys tu dah boleh guna a lot for other systems. Transys can also be an input to even MATLAB sekarang ni. So tak ada masalah. So one, MATLAB kena ada, and then the Transys you can start a new program, you boleh bagi student you untuk buat a lot of work. So, and the next one is that most of you are in the heat transfer. So, and also kebanyakan dah ada heat transfer. So, one step ahead untuk you pergi adalah basically to upgrade you punya heat transfer lab. So you can look at different configuration, because banyak sangat tube dalam solar collector ni. So you can increase by even using micro channels, using micro fins dan sebagainya. You can find the heat transfer correlation for it, and you can publish a lot of papers. And also try to get those equipment yang to when you want to involve with nanofluids, you can have this simple equipment to and one last thing that you need to have is this simulator. Dipanggil solar simulator. It's a collection of tungsten ataupun lamp yang ada untuk buat indoor simulation. You can just take any of because semua ni dah bukan pattern lah, it's not, you just get the thing and then you can do a lot of experiment using a lot of configuration as you wish. You can use that for air-based collector, also for water-based collector, even for photovoltaic thermal collectors. Yeah. So again, number one, good software. Number two, good heat transfer lab, especially for mechanical engineering. And number tiga, a solar simulator. You kena ada. So these are the three things that if you want to start something, we in UKM, we start with a very simple simulator zaman-zaman dulu. And then sekarang ni, kita ada lebih kurang dalam 4 simulator kat tempat kita. Then the student kan. Dan yang latest sekali adalah you even can control the inlet of the collector. So these are the things that is required. So setakat itu saya punya ni. Kalau ada persoalan saya boleh jawab.
Okay. Thank you so much, Prof. Kamaruzzaman Sopian.